Hi, I'm Phil, and welcome back to the Mount Druitt STEM Club. This week, we're going to look at topic 2, time projects. And I've reduced these so you can do them with the modules that are in your bit gadget kit. And you should be able to do at least the first project today. So let's just advance. I'm going to use a mind map, and we'll start off with the objectives, talk about the components you'll be using. You've already been introduced to both the Grove system and the modules in your bit maker kit or the bit gadget kit contain quite a number of Grove modules. And we've already looked at makecode to make our name badge. And today we'll have a look at some projects, and I'll suggest some other projects you might like to look at. And we'll finish off with a review, and there are some references if you want to follow up some of these activities. So the objective for today is to learn a bit more about sensors and actuators. And this time, we'll be using a sensor called the accelerometer, and it measures acceleration. And this is one of the sensors that's on board your microbit computer. And we'll be using an actuator, or two actuators. One will be the LED array, which is also on board the microbit, but we'll also use an actuator which you plug in to the bit maker using the Grove connection. And this will be a neopixel array. So we'll learn a little bit more about makecode. And we've got two interesting extensions. One is a RTC, and that stands for real-time clock. And the other one is neopixels. And we'll be using the LED pixel array. So we've got the LED pixel array represented both in hardware and in software. And in the Grove system, we'll be using the neopixel LED strip. So perhaps you can explore a little bit more outside the class today with how accurate clocks are. And I wonder how accurate our clocks are in each of the projects today. And all these clocks can be used in many activities, both at home, to do with your measure the time you're taking to do your homework. It can be used in science and medicine, transport, and of course sport, where we use the stopwatch. And so the components we're using: the microbit, bit maker. Another piece of hardware we'll be using will be the, in the Grove modules, the neopixel LED strip. See if you can find that. See if you can find both bitmaker and the neopixel LED strip. And the projects we'll be looking at will be a basic watch, quite a simple one. And if you're doing quite well with that and you've got a bit more time, for the first two projects, will take about 20 minutes. But if you're doing well, you can do the second project, and that's looking at a softRTC, or a software real-time clock. And finally, we'll look at a countdown timer. This will be a presentation timer. So if your teacher asks you to do a simple presentation in 30 seconds, you can use this timer. And we won't have time for the stopwatch, but you can follow up the references that I've got here, and you can see a little bit more about using time projects. In the base, this is the basic project and the software, and we do this in makecode. And on the left, we've got the startup, we've got the forever, and this is on the right. We set the buttons. We use the buttons to set the minutes. So on startup, we're going to initialize the variables, and we've got 3 variables here: hours, minutes, and seconds. And we've set this up for 1600 or 4 o'clock in the afternoon. Minutes, we've set that at 0, and seconds, we've set that also at 0. So in the forever loop, we're going to break this down into 2 parts. In the first part, we wait for 1 second, that is 1000 milliseconds. And at the end of that time, we increment the seconds by 1. So seconds goes from seconds to seconds plus 1. Now, if the seconds is 60, we need to reset it back to 0. And we need to increment the minutes by 1. So that's the first part. So guess what's in the second part? Well, it's a bit of a repeat. So if the minutes equals 60, we set the minutes to 0, and we increment the hours by 1. And after we've done that, we show the hours, and that will scroll across the microbit LED screen, and we show the minutes on the same LED screen. Now, a much more advanced project is to use the extensions to import a software real-time clock. And this is the whole program. And it's quite advanced in that it not only sets the hours and the minutes, but it also sets the hours with the accelerometer. So here we're using the accelerometer to show the time. So when you shake your watch, it will show the time. And if you tilt the watch left, it will increment the hours by 1. And if you tilt it right, it will decrement the hours by 1. And we use the buttons A and B as we did before. So let's have a look at this. What we do is we go to the extensions and we import the software real-time clock. And these are the modules. And the particular ones we'll be using will be the set time. So we'll be using an AM, or you could select a 24-hour, but we'll be selecting the one on top. And the other one we'll be using will be selecting time. And this automatically imports hours, minutes, seconds, months, day, and year as variables into our variable list. So on the start, I'm just setting the name of the program, which is watch, and it's WB6. And the first thing I'm going to do is reset the watch. You'll notice that there was nothing in the forever loop. So in resetting the watch, I'm just setting the time to 16 for hours, 0 for minutes, and that's in the middle. And on the right, we're setting the seconds to PM. And I'm introducing another function called showtime. And here we use a block, and the block is a time block using the variables. And I'm particularly using the hours and the minutes here. So I'm showing on the microbit LED the hours, followed by a colon, then the minutes. And that's all there is in showing the time. To use the accelerometer, we go to the input and we look at the shake. So we drag that across, and as soon as we shake, we call showtime. And that's all there is in showing the time. And for button A, we do what we did before. We increment the minutes. And again, we use the block time as numbers, and inside that we set the time and increment the minutes by 1. So we're incrementing that. And we do the same or similar with button B, and we decrement the minutes by 1. So when you press button B, we just subtract 1 from the minutes variable. And after we do that, we show the time. And we do something similar with the hours, but we're going to use the accelerometer to do that. So when we tilt the microbit, it will, when we tilt it left, it will increment the hours, and we decrement it by tilting it right. So that's the presenters. So that's the more advanced clock using a software real-time clock. Now for our last project, we're going to have a look at the presenter's timer, where we use the neopixel LED array. And on the start, we set the variables. Count how many LEDs you have in the LED strip. Well, there are 30, so we set the LED max number, or LED max, to 30. We're going to set the maximum time to the same number as the LEDs. So 1 LED is going to represent 1 second. And the time left initially is going to be set to the time max, which is 30. And the next variable, we use the extension again, select the neopixels, and we select the neopixel is going to be plugged into P2 on the bit maker. So plug that in now, plug in the neopixel array into the port 2 of bitmaker. And it's going to have a maximum number of 30, and we be careful setting the model. So we're going to use an RGB, but it's going to be in GRB format. Then we're going to gradually show less and less pixels as we've got less time for our presentation. And we do that with range. So it's going to use the strip from 0 to the maximum number, but we'll change that later in the program. And right now, the presentation is going to be set to false. So that's a logic. So if you look at the logic blocks, you have a choice of true or false. And at the moment, we're not starting the presentation yet. Then we reset the display. And in the forever loop, this is the first part of it. If the presentation is on, we show how much time is left. And we wait for 1 second. Then we decrement or reduce the time by 1. And then if that time is 0, we show a red on all the LEDs and we play a tune. And at the end of all that, on the microbit LED display, we show a cross. That is, time's up for the presenter. So in the forever, in the second part, we reduce the number of LEDs by 1. And that's the time we're letting the presenter know how much time they have left. And we show that on the LED strip. And to reset the display, so what we want to do is get ready for the next presenter. And we let them know, because the color that's chosen here for the LED strip is blue, and the whole strip will go blue. But the presentation hasn't started yet. And we play a melody and show that color on the LED. So in the presenter's timer, we've already started off with the on start. But we still have to look at what happens when we press button A, B, and together A plus B. And we've also already done the other one, which is the forever and the reset display. So button A, what we're going to do here is if the time is greater than Tmax, we reset the time. And we're going to use button A to increment the time by 1. But we are going to set a maximum of time max. That is no more than 30. If it's 30, we go round and reset the time to 0. We play a note for 1 beat, and we show how much time is left on the LED array. And then we reset the display. And we do something similar with button B. But button B is going to, if we look down, it does the opposite from button A. That is, it decrements the time left by 1. But when it gets to 0, it doesn't want to show time left as a negative number. It resets that to time max. And if you want to start the presentation, you press the combination of button A and B together. And that will show on the microbit LED array a tick and show green as the color for the presentation. So the presentation is now true. Okay, so that's all the projects for today, but there are lots of challenges. And one challenge is to show the time of both hours and seconds in a different format. So this project would use binary coding of the display for both the hours and the seconds. And if you do this, you can show the time on the one display without scrolling. And some of the other ones are for logging events, and that could be for an alarm. If an alarm goes off and you want to record the time, you can give it a time stamp. Or you could have an activity for swimmers, such as a stopwatch. Or you could use it for when you're cooking eggs, boiled eggs, you can have a timer, say a 3-minute timer. Alternatively, you could use it for traffic lights, or even use it to minimize the time that you take for a shower. So in a review, what did you learn today? Well, one thing was we used some extra blocks, and 2 of them were used in the projects. The first one was the software real-time clock, and the second one was the neopixels. So we use makecode extensions for those. And we also learned what a real-time clock was. And if we had a bit more time, we'd be able to see how accurate our first and our second real-time clocks were. And is there a way to improve the accuracy of that clock? So how did your projects go today? And are there any other projects that you would like to do? Okay, so here are some of the references. So if you look up the microbit and look up stopwatches or clocks, you'll get plenty of other information that will help you with your projects. Okay, and that's it for today. That's all there is.